Hi guys, this is Dr. Callahan for probability for week 5, Tuesday. So go ahead and pause the video for your 3 questions on your warm-up log. All right, question number 3, what are your plans for Halloween? I'm not sure if Halloween's not happening this year, so we shall see what happens in October. So previous years, my little boys actually dressed up as Mario and Luigi. And yes, I made their costume. It was the one and only costume I ever made for them. So last time I saw you guys online was yesterday, and we were supposed to be doing a gallery walk with a Venn diagram. Well, it's a little hard to be able to do that when we're not here in person. So yes, make sure you turn that in when I see you guys next time after all these virtual days are over. So today we're going to continue with 11.3 and 11.4, which is on combinations of fundamental probability. We're going to go over page 5, examples 1, 2, and 3. We're also going to be working on objectives 4, 5, and 6 on page 19. You should have your unit 2 white packet. And then tonight's homework is number 30 to 44 evens. You don't need to worry about the quizzes or the Kahoot because we're not here together in person. And then you have one exit ticket that you just need to copy down somewhere in your packet. So with that said, make sure you guys have your packet so that way you can take the notes down. And as always, you're allowed to use that on your quiz. So it is important for you guys to make sure you have it available. All right, let's go ahead and take a look at question number 11.3 and 11.4. Go ahead, or sections 11.3 and 11.4. Read the objectives, and we shall continue with this. So the first one is a combination of items occur when the items are selected from the same group. No item is used more than once. The order of the item makes no difference. So order does not matter. So what are some examples? The way I kind of remember this with combination is like a locker combination, where the order does not matter. Well, like for example, if you have a locker combination, if you have 26, 17, and 2, does the order matter? Absolutely. Because if I go ahead and type it, or if I dial the locker as 17, 26, and 2, would that work? Nope. So a locker combination is going to be a permutation, where the orders actually does matter. Okay, so a locker combination, even though it has the word combination, really is not a combination because it is a permutation. Okay, let's go on to example number 1. Go ahead, read the question. It says for each of the problem, determine whether it is a permutation where order matters, like the locker combination question, or combination where order does not matter. Okay, so for A, 6 students are running for student government president. So there's a president, vice president, treasurer. Obviously, in those positions, it matters, like being in first place, second place, or third place. So this is where order matters, so it will be a permutation. B, 6 people are on the board of supervisors in the neighborhood. It is going to have a 3-person committee, and it's going to be formed from 6 people. This one is a combination because order doesn't matter. If I get chosen as one of the 3 people out of the 6 to be on the committee, then that's all that matters. I don't really care if I'm one of three people, two of three people, or three of three people. The order absolutely does not matter because I got chosen. So I'm a happy gal. C. Baskin Robbins offers 31 different flavors of ice cream. One of their items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many bowls are possible? In this case, it's also a combination. Order does not matter. So if you're looking at combinations like questions with B or C, you will be using the formula NCR. And remember, N is always going to be the bigger number, and R is always going to be the smaller number, which is going to be equal to N factorial, N minus R factorial, R factorial. Okay, example 2. A 2-person committee is needed to study ways of improving public transportation. How many committees can be formed from the 8 people on the board of advisors? Well, this one obviously is a combination because order does not matter. So let's take a look at the 2 different numbers. I have 3 and 8. I'm going to label the N. N is always going to be the bigger number. R is always going to be the smaller number. So you know that NCR equals N factorial over R factorial times N minus R factorial. Well, let's plug in the numbers. You have N is 8, so N 8 factorial, 3 factorial times 8 minus 3 factorial. So that's going to give me 8 factorials on top, 3 factorial times 5 factorial, because 8 minus 3 is a 5. And remember the factorial, you just go in descending form, 8 times 7 times 5, 6 times 5 times 4 times 3 times 2 times 1. So I'm going to do 8, 7, 6. I'm going to stop right there with 5 factorial. And the reason why I did that is because you have 3 times 2 times 1 times your 5 factorial. And I kept it that way so that way I can just cancel it instead of writing the entire thing. 5, 4, 3, 2, 1. I mean, you could, but it just takes a little bit of time. So just cancel that. That's fine. Now I'm going to go ahead and reduce this a little bit further. 8 and 2. 8 divided by 2 is going to give me a 4. 3 and 6. 6 divided by 3 is going to give me a 2. So my answer is going to be 4 times 2 times 7. On the bottom, I only have a 1 left. So what is my answer? 56. So in this 3-person committee, there are 56 different ways of creating that committee. Okay, example 3. Go ahead and read it. In a poker game, a person deals with 5 cards in a standard 52-deck card. How many different 5 cards hands are possible? So again, it's a combination question. So I'm going to label my R and N. So my N is going to be the bigger number, which is 52. R is going to be my smaller number, which is 5. So I'm going to have 52 C 5 equals. And remember, your combination is going to be N factorial over N minus R factorial. Trying to figure out my eraser as. Here we go. Times R factorial. So 52 minus 5. Or oops, you know what? I jumped the gun a little bit. So give me a second. Let me fix this. 52 factorial over 5 factorial times 52 minus 5 is going to give me a 47 factorial. So let's go ahead and do the factorial itself. So I'm going to do 52, 51, 50, 49, 48, and I'm going to stop at 47 factorial because I'm going to be able to cancel it with the denominator. And at the bottom of this, you are going to have 5, 4, 3, 2, 1 times 47 factorial. And look, guess what? You can go ahead and cancel the 47 factorial directly. Boom, boom, gone. Now I just want to reduce the numerator a little bit. Okay, so I know I have a 50 and a 5. So 50 divided by 5 is going to give me a 5. And then I have a 48 and a 4. 48 divided by 4 is going to give me a 12. And then I have a 51 and a 3. 51 divided by 3 is going to give me a 17. And then I have a 12 and a 2. 12 divided by 2 is going to give me a 6. See how easy that was? You just have to reduce it down to the bottom. So then what is my answer? Well, you can't forget the 52 here. So by 52 times 17 times 5 times 49 times 6 over 1. And if you have a calculator and you multiply that out, how many different combinations can I have with 5 cards in a 52 card deck? It's going to be a doozy. 2,589,960 different possibilities. That's why whenever you gamble, the house always wins, because there's just way too many different combinations that goes in their favor. All right, you guys, that's pretty much it. Make sure you guys remember to do your homework on your Google Doc. And remember, you want to look for a week 5 Tuesday for your textbook on that. Okay, now let's go ahead and practice a little bit with your different objectives, okay? All right, so for A and B, make sure you guys go ahead and read it. In how many ways can the letters in the word osmosis be arranged? So for this one, it is going to be a order, and order does matter. So it will be a permutation. A permutation is going to be NR equals N factorials over N minus R factorial. Now with this one, because it is on letters of the words, this is kind of like Mississippi, okay? I think when we did that one, the one we did with Mississippi, it was N factorial over P factorial, Q factorial, R factorial, S factorial, just depending on how many times a letter is repeated. So looking at osmosis, how many letters are there in all? 1, 2, 3, 4, 5, 6, 7. So 7 is my N. Then my P is going to be my first repeated letter, which in this case is going to be the letter O. And it's repeated 2 times. Q is going to be my second repeated letter. And in this case, it will be the letter S. And it's repeated 3 times. And that's it. There's nothing else that's repeated again. So I would do 7 factorial divided by 2 factorial for the P, 3 factorial for the Q. So let's simplify this. 7 times 6 times 5 times 4 times 3 factorial. Don't forget your 2 factorial, which is just going to be 2 times 1. Times, don't forget your 3 factorial.
And you can go ahead and directly just cancel this part out. 4 divided by 2 is going to give me a 2, and that's as much as we can cancel. So then your answer is going to be 7 times 6 times 5 times 2. So the different ways that you can do this is going to give you 420 different times. And that is your answer. You guys can go ahead and do Tallahassee. I'll help you set it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is your N because there are 11 letters. P is going to be the first letter that's going to be repeated. And I could say that's going to be the letter S. And it is repeated twice. Q is going to be the next letter that's repeated, which is going to be the letter E. And it's also repeated twice. Any other letters that's repeated for you? Let's see, we got P or S. We got E, O, and L. So then we will need Q, then R. R will be the letter L, and it's repeated 1, 2 times. And we will have to do S, which will be the letter A. And it's repeated 1, 2, 3 times. Yep, I think that's it. So then you're going to plug this into your equation, which is going to be 11 factorial over 2 factorial, 2 factorial, 2 factorial, 3 factorial. You show the word to get this one done. And let me just give you the answer. 92,400. Let's go ahead and take a look at objective number 5. Actually, I'm going to have you guys take a look at objective number 5. I'm going to have you guys try it. Okay. Objective number 6. Let's do a little bit of practice with combination. So again, you want to go ahead and memorize a formula, which is n factorial for combination, r factorial times n minus r factorial. You guys do A, which is the result in 6. I will go ahead and do the last 2. You do B, and B is going to give you 126. Make sure you show the work. I will go ahead and do C. For C, you know your N is 30, your R is 3. So when I plug this in, it's 30 factorial divided by 3 factorial times 30 minus 3, which is 27 factorial. Now this initially looks really scary because it has really big numbers, but you don't have to go 30, 29, 28, 27, all the way down to 1. You could just do 30 times 29 times 28 times 27 factorial and stop there. And then you're going to do the same thing on the bottom. 3 times 2 times 1 times 27 factorial. And guess what? You can directly just cancel these two away from each other and then simplify the rest. You know 30 divided by 3 is going to give you a 10. You know that 28 divided by 2 is going to give you a 14. So then what I have left here is I have 10, 29, 14, all divided by 1. And if I go ahead and multiply that together, I will have 4,060 different possibilities. Let's take a look at D. With D, you have a combination divided by a combination. So I'm going to do the first combination first, okay? And I know it looks kind of, you're like, oh my gosh, that's a lot. It's actually not if you just memorize a formula. So I'm going to have 7 factorial on top. 7 minus 3 is going to be a 4 factorial times 3 factorial. So 7, 6, 5, 4 factorial. 3, 2, 1 times 4 factorial. And this part cancels. You know, 6 divided by 3 is going to give me a 2. And guess what? That 2 and the bottom 2 cancels. So 7 times 5 is a 35. That's your answer for the numerator. Now let's go ahead and work the denominator combination. So start out with 5 factorial divided by 4 factorial times 5 minus 4 is 1 factorial. So I'm going to do 5 times 4 factorial divided by 4 factorial times 1. And this one's pretty easy because the 4 factorial cancels. 5 divided by 1 is just going to be 5. Now I can divide that. 35 divided by 5 is just going to give me 7. And that's my answer for letter E. Let's go on to letter E. Go ahead and read the question. You guys go ahead and set this one up. The answer is going to be 20. If you need to take a look at the work, go ahead. All right, you guys, this is your exit ticket. How do you feel about today's lesson and why? If you need to make up any work, make sure you guys go to my Google Doc with all of your homework activities, which is right here, capital C, capital U, capital W, lowercase f, lowercase c. If I do go to it, this is what you will see. Today is week 5 Tuesday, so you're going to scroll all the way down, past all the other weeks, and those assignments. So we're on week 3, so let's keep going. Week 5, here we go. So week 5 Tuesday is going to be right here. Oh, actually, that's week 4. Just kidding. I did see it at one point, but I think I skipped it. Okay, here we go. Week 5 Tuesday. So it gives you your classwork, gives you the links, and on the very bottom, you have your textbook work right here. So you can go ahead and get started with that. All right, you guys, it was nice chatting with you guys, and I'll see you guys next time. Take care.